Welcome back to video 5 on Introduction to Polar Coordinates. In this video, we are going to be going the other direction. Instead of going from rectangular to polar, we're going from polar coordinates to rectangular coordinates. So the first thing I'm going to do with r equals 4 over 1 plus sine theta is clear the fraction. I'll do that by multiplying both sides by 1 plus sine theta. This will give me r times 1 plus sine theta equals 4. I'll distribute the r, and that will give me r plus r sine theta equals 4. From here, I'll replace the r sine theta with y. That gives me r plus y equals 4. And from here, I'll isolate the r by subtracting y from both sides. Now I have r equals 4 minus y. I need to square both sides to have something that's familiar to do a substitution. Now I have r squared is equal to 4 minus y times 4 minus y. That's the same as 4 minus y squared, but it's maybe a little bit easier to see how to do this by foiling this out. I should get 16 minus 8y plus y squared on the right side equals r squared on the left side. I know that I can replace my r squared with x squared plus y squared. And then I'll just rewrite everything on the right side, 16 minus 8y plus y squared. And then I'm going to subtract y squared from both sides. This gives me x squared equals 16 minus 8y. Just for formality's sake, we're going to add 8y to both sides. And we get x squared plus 8y equals 16, and that's my answer. Now let's look at r sine theta equals 3r cosine theta plus 2. The r sine theta I can replace with y. The r cosine theta I can replace with x, and that will give me y is equal to 3x plus 2. Subtracting 3x from both sides gives me y minus 3x is equal to 2. The next example gives us r is equal to 2 times 1 plus cosine theta. If we were to square both sides of this equation, we would not be able to do anything with the cosine theta because it wouldn't have an r connected to it. So instead, we're going to multiply both sides of this equation by r. This will give me r times r equals 2 times r times 1 plus cosine of theta. And then if I distribute, I will have r squared is equal to 2r plus 2r cosine theta. And I can replace the r cosine theta with x. This gives me r squared is equal to 2r plus 2x. I'll go ahead and subtract the 2x from both sides. And replace the r squared with an x squared plus y squared. This isn't entirely helpful yet because I still have this r here, and that is a problem. I need to figure out how I'm going to make this work. I have x squared plus y squared minus 2x equals 2r. And now I need to square both sides. This will give me x squared plus y squared minus 2x all squared equals 4r squared. And now I can replace the r squared with an x squared plus y squared. And this doesn't really get much nicer. We could leave it like this. We could divide both sides of this by 4. But it's pretty ugly. So we'll just leave it like this. X squared plus y squared minus 2x quantity squared all divided by 4 is equal to x squared plus y squared. Let's take a look at tangent of theta equals 1. Remember, tangent of theta in our conversion formulas is the same as y divided by x. So we can just say that y divided by x is 1. If we wanted to clear the fraction, we could simply multiply both sides of the equation by x, and we would have y equals x.